We've seen graphs like this before, but we've only seen them with one line on them. This is a graph of a cubed versus t squared. This is an illustration of Kepler's third law. It shows that there is a relationship between a cubed and t squared, that they are proportional to each other. Remember, a is the length of the semi-major axis of an orbit, and t, capital T, is the period or the length of a year for that orbiting body. Now, it's also important to remember that the semi-major axis is the distance from the center point of the orbit to the edge of the orbit along the x-axis, so the longest distance. But it's also the length of the semi-major axis is also the average distance of the planet from the sun. So when we saw this graph with one line on it, it was this purple line, or red line, that represents the planets around the sun. Here we also see a line for planets around Gliese 876, which is another star that is smaller than the sun or less massive than the sun. And we see a line for Earth's satellites, which is, of course, much, much, much smaller than the sun. Let's look across this graph. Let's look at, for example, uh, let's look at what happens if the semi-major axis for a planet is zero point zero 0.03, 0.03 astro. Well, the cube of the semi-major axis is equal to zero point zero 0.03 astronomical units cubed. Okay, so here's where we're going to look across. Well, if a planet is that distance from the sun, we look left to right, we see, okay, so that means that it would intersect this graph from the sun for the sun at this point, and then we could look down and we could see that that would mean that uh, the period squared for that planet is a little less than zero point zero 0.03. So the length of a year on that planet is about the square root of zero point zero 0.03, or a little less than the square root of zero point zero 0.03. Now, if we look at another planet that's the same distance from Gliese 876, it intersects the graph at this point. So a planet orbiting Gliese 876 at where the cube of its semi-major axis is equal to zero point zero 0.03, that would mean that its year lasts the square root of zero point zero 0.09 years, or zero point zero 0.03 years. The point of this graph, you may have to replay this to follow all of that or do the reading along with it. But the point of this graph is to show you that different slopes, different central bodies have different slopes on this graph. You could put all the planets and all the asteroids and all the comets in the solar system, they would fall somewhere along this line for the sun. All of the bodies orbiting Gliese 876 would fall somewhere along this line. And all of the satellites orbiting Earth, that includes the moon, the International Space Station, any satellites up there, would fall along this yellow line. So the mass of the central body determines the slope of the line, because the more massive the central body is, the faster the planets or the satellites will orbit around that central body, and the shorter the years will be for those satellites.